Okay, so I'm going to present you the work that I've conducted for my M2 internship with Thierry Nazy and Sandrine Van Omen, which is about segmental biases in lexical processing assessed with a familiar word recognition conflict task. So first, a bit of background. So we know that consonant constrain lexical access to a greater degree than vowel, and this has been named in the literature the C bias. And this bias has been investigated with many different experimental methods and consistently found in adults, but not so consistently found at the developmental level, which suggests that segmental biases in lexical processing are acquired and language dependent. So about the C bias in adulthood, so there's Nazy and Cutler who reviewed 38 studies in 13 different languages assessing the C bias. And so this table right here summarizes their finding, but in a nutshell, what they found is that 23 out of 38 studies show the C bias. And importantly, no study showed a stronger lexical relation for vowel alone. And so suggests that in adult spoken language, lexical processing is more strongly associated with consonant than with vowel. At the developmental level, the picture is a bit different. So you can see here a table that summarizes a children's study. And so, for example, here you can see that French, Italian, and English show C bias, but that the age of emergence vary between languages. So for example, the C bias emerged between 6 and 8 months for French children, whereas it emerged between 23 and 30 months for English children. And also, importantly, Danish children and Cantonese children do not show C bias, but are rather biased toward vowels during lexical processing. And so that suggests that the C bias is acquired and language dependent. And so to explain this mechanism, 3 hypotheses have been proposed in the literature. So there's the acoustic phonetic hypothesis, which states that the C bias is based on acoustic differences between consonant and vowel. In contrast, there's the lexical hypothesis, which states that the C bias is based on the structure of the lexicon. And finally, there is the lexical hypothesis, which states that the C bias is based on both the phonetic and the lexical properties of the native language. And so the lexical and acoustic phonetic hypotheses should be seen as complementary. And so in this context, the present study aimed at replicating the previous findings showing C biases in lexical processing among French adults and children, with a relatively new experimental task, which is a familiar word recognition conflict task. And the secondary objective of this study was to assess the extent to which the consonant bias in lexical processing would interact with the relative position of the consonant and vowel in the word. So to do this, we've tested 25 French monolingual adult and 18 French learning 24 months old in an intermodal preferential looking paradigm. And we used an iLink eye tracker to capture the participants' gaze. So you can see right here an example of a conflict task. So in this trial, the participants were presented with 2 pictures, the picture of a singe and the picture of a soup. And at a certain moment in the trial, they heard an auditory target, which was a mispronounced word, in this case, simp. And this mispronounced word differed by a consonant from singe and by a vowel from soup. And so in this conflict situation, there's the possibility to consider either the consonant or the vowel difference as critical for lexical access. And the C bias would predict that the consonant difference should matter more, and so that participants will tend to look more often at the soup. So in this table, you can see all the words that we've used in our experiment. They were organized in 8 fixed word pairs. So these are the well-pronounced words, and these are the mispronounced words, in which each mispronounced word differs from one of the well-pronounced words by a consonant and by the other by a vowel. And importantly as well, for the mispronounced word, in half of them, the consonant mispronunciation was situated at the onset of the word, whereas for the other half of the word, the consonant mispronunciation was situated at the coda. And so all of these words were used in experiment, resulting in 32 experimental trials, with 16 control trials in which the participants heard a well-pronounced word, and 16 conflict trials in which the participants heard a mispronounced word. And so about the trial structure, each trial lasted 6 seconds. And the trial started when the two pictures appear on screen. They remained in silence for 2,133 milliseconds, in which the auditory target was present to the participants, and then the picture remained until the end of the trial. And so for our analysis purposes, we divided the first 5 seconds of each trial into, with the pre-naming phase, which was the first 2.5 seconds, and the post-naming phase, the subsequent 2.5 seconds. And in this phase, the participant's gaze should be influenced by the auditory target. So in terms of statistical analysis, we used linear mixed effect models for all our analysis, and the dependent measure was always the proportion of target looking, with the target being defined as the picture labeled in control trial, or the picture associated with the vowel mispronunciation word in conflict trial. And we conducted two main types of analysis. So window analysis, in which we evaluate whether there are differences in proportion of target looking between the pre-naming and the post-naming phase, and growth curve analysis, which include time as a predictor to estimate if processing difference between conditions emerge over time. And so these are the results of our window analysis for the adult data. So here we compare the control trial with the conflict trial. And so for both conditions, there was a significant increase in the post-naming window of the PTL, but this increase was larger for control trials than conflict trials. And so this result suggests that adults understand the word they were presented with when they were well pronounced, and exhibit a C bias when they were presented with mispronounced word. Then for a second analysis, we only took the conflict trials and looked at whether there were differences between onset conflict trials and coda conflict trials. And in this analysis revealed that the significant differences increase in PTL in the post-naming window was only present for the onset conflict trial, whereas participants' PTL was a chance for coda conflict trial, which suggests that the position of the mispronounced consonant plays a role in the emergence of the C bias. So about the growth curve analysis, we did the same thing, two analyses. So first we compared the control and the conflict trial. And so as you can see here, for the control trial, there was a sharp increase toward the target, of looks toward the target. And then it remained stable during the whole post-naming phase, indicating a fast recognition of the word. Whereas for the conflict trial, there was a slow and steady increase during the whole post-naming phase, indicating still a C bias, but a slower recognition of the word. And when we looked only at conflict trial, we can see that for coda conflict trial, participants tended to look first at the destructor at the beginning of the post-naming phase, and then started to look toward the target, increase their looks toward the target during the rest of the post-naming phase, whereas for the onset conflict trial, they only increased toward the target during the whole post-naming phase. For the children, the picture is a bit different. So we can see here when we compare control and conflict trial that only there was a significant increase in PTL only for control trials, which shows us that children recognize the word when they were well pronounced. But in the conflict condition, their proportion of target looking was a chance even in the post-naming window. So this suggests that they do not exhibit a C bias in our task. And when we look only at the conflict trials, the only significant interaction that emerged is an interaction between position and trial order. And as you can see here, there was a significant increase in PTL across the two windows. And so the participants' PTL tended to increase as more trials were presented to the participants. And so for the growth curve analysis, we can see here that in the control trials, even children looked quickly toward the target in the post-naming phase, and then around 3.5 seconds started to explore again the picture, whereas for the conflict trial, they were basically a chance. And when we look only at the conflict trial and separate them between onset conflict trial and coda conflict trial, we see an interesting pattern in right here. And so for coda conflict trial, participants tended to look more at the distractor at the beginning of the post-naming phase, and then switch their look toward the target again during the remaining post-naming phase. So this can be explained by the fact that in coda conflict trial, the first two segments of the word were congruent with the distractor. So for example, if the participants heard simple, the distractor was singe, so the first two segments were congruent, and the target was soup. So this suggests that speech is processed continuously. And so in summary, our findings show that French-speaking adults give more weight to the consonant than to the vowel in lexical processing, and this is in line with previous finding, and suggests that the C bias in French adult population extends to all facets of lexical processing, including familiar word comprehension. For the children, the results were a bit more surprising since they contrasted with several studies showing that C bias was present in French children even when they were younger than 24 months old. And so we considered three potential hypotheses to explain such findings. So first, the results presented here were only preliminary because they were based on 18 children, whereas we have planned to test 24 participants in total. So maybe our sample size might not be sensitive enough to capture the effect of the C bias. A second hypothesis could be related to the conflict task. So because this task directly put into conflict consonantal and vocalic information, and there is no clear answer, this might have confused participants, and especially younger ones, and so might show a reduced sensitivity to the C bias. And finally, a third hypothesis would be related to the familiar word recognition task. This is a task which tap high-level lexical processing, so the activation of words stored in long-term memory. And so it's possible that this task might be more sensitive to every kind of mispronunciation, including vowel mispronunciation. And so the asymmetrical weight between consonant and vowel might be reduced. And finally, regarding the position of the consonant, our findings show that adult participants increase their look to the target object more often when the conflict involves an onset, which this is in accordance with the C bias. But when the conflict involved coda, they were basically a chance. And similar positional effects were found in children time course analysis. And this suggests that performance in lexical access is sensitive to positional effects. And so the processing of speech is continuous and phonemes are processed as they are being heard. And secondly, performance in lexical access is also sensitive to the consonant bias. So French participants place more weight upon a mismatch on a consonant in onset than a mismatch vowel for lexical access. But no asymmetry is found in conflicting situation between a vowel and a coda. And this suggests that the consonant bias interferes with the positional bias. And that's it. Thank you for your attention.